Hello, from Team Half-Life, based out of Fairfax High School, and today I will be presenting our garment design for the NASA Wear Challenge. So our first thoughts when looking at the challenge were, well, if we're trying to reduce the effects of radiation, then why not just build a garment made out of hydrogen-rich materials that's just like solid material? But then we realized, well, that would limit the mobility of the user. So inspired by biomimicry and fish, we came up with the concept of scale mail. So what's great about scale mail is that it allows you to use rigid materials, but it still allows the wearer movement because of the way that it overlaps. Then we decided, well, why stop there, right? So we decided to apply our scale mail design to our previous year's design in order to improve it. So I'll run you through our cross-section here. We got a layer of polyester. This is what's touching the astronaut's skin, or if they're wearing like a shirt or something when they were putting on the garment. Then we got a water and polyethylene system. The purpose of this system is to reduce the launch costs, because you can launch this garment without any water, and then once it's on the spacecraft in space, and you're given notice of a solar particle event, you can pump it full of water in order to increase the protection provided to the wearer. Then we have our polyethylene scales. What's great about this is that if for some reason it were to be damaged, these scales can be just swapped out. And then we have a layer of polyethylene again, and what this one does is prevents any snagging on the polyethylene scales. And the reason we use two different densities of polyethylene in our design is because while the higher density polyethylene provides more protection, it's more rigid. So the only place it's feasible to use it in our design is for the scale mail. It's not usable in the polyethylene water system without restricting the movement of the wearer. And the reason we chose to use polyethylene and water in the first place is because if you look at the graph, they're some of the most effective materials at reducing radiation. So this is our 3D concept diagram. This is how the water gets into the garment. It goes in through the top through a garment valve, and then the water displaces itself into other sections through solid water transport openings. So this is the pump I just mentioned. We felt like it wouldn't be right to just say we pump water into the vest. So we decided to, design our own pump. While there are systems that can pump water, typically aboard spacecraft, since electronics can be unreliable at times during solar particle events, we decided to design this mechanical backup. So this is the garment design itself. If you look at the top view, you can see that you just put your head through the top, smooth down the front, and then just bring the back to the front. And if you look at the front view, you just use the buckles and straps to just secure it in place. And what's great about this design is that it protects the vital blood forming organs and the reproductive system. And it's pretty feasible. The hardest part is the scales, and even that can be CNC'd out of a sheet of high density polyethylene. I think the greatest limitation of our design is the multifunctionality. I mean, don't get me wrong, it still has a good amount of function. You can hang it up above crew quarters to provide some protection. Technically, you can fill it up with water and store water in there if for some reason that's desired. But next year, I think a greater emphasis is going to be placed on the multifunctionality of our design. So what we did to get our garment to be able to fit the tallest male to the shortest female is we used anthropometric data from the NASA website while dimensioning our vest and calculating the surface area. So it would be able to fit these different ranges of people. I think the biggest challenge was getting it so that the armholes made sense. So if you have, for example, an apron and it's too large for you, you can still move around. But if you're wearing an undersized t-shirt, then the armholes are going to be too small for you and you can't move. So how we got around from this is with our bringing the back into the front design, it allows you to create an adjustable arm opening. Now on to a demonstration on how to put on the vest.
So this is our vest design. To wear it, I'm going to start off by taking the head hole and putting it through her head. Now I'm going to take the front of her vest and just flatten it down over the front of her body. And I'm going to do the same with the back. And these straps coming out of the back, I'm going to take them and attach them to the front of the vest and do the same on the other side. And there you go.
To optimize our garment's performance, our team first performed some critical mathematical calculations. For example, we first calculated the unfilled launch weight. The unfilled launch weight is the total weight of the garment prior to the pockets being filled by water. This is how heavy it will be as it is sent up into space. To calculate the unfilled launch weight, we first calculated the total volume of the garment by multiplying the approximate surface area by the total thickness. We then multiplied the volume by each of the material's densities and respective proportions to obtain a final value of 19.559 pounds. We then performed a similar analysis when calculating its filled weight, but by also accounting for the total amount of water that would be in the pockets. We found this value to be 28.684 pounds. Finally, we also found our garment's areal density to be approximately 3.14 grams per centimeter squared. Our team also performed a lot of outreach within our school's community. We volunteered at 2 separate course selection fairs and advertised NASA Wear as an incentive to participate in the school's STEM programs to over 100 high school students and over 300 middle school students from our local middle school feeder. Thank you for listening to our presentation. We look forward to hearing your comments and feedback.